So welcome everyone to episode 2 of Get It Right in Black and White. I'm just so pumped to do this. So we've got Adil here, we've got Nita here, some others may join. But in the meantime, we can start. Episode 2 is going to be about pseudo visualizations. What that means is we're going to use basic SVG shapes to approximate visualizations. And this will make sure that, we really grok the fundamental shapes that go into making visualizations. What we'll cover today, and this is aspirational, I may not get to all of these, but I am going to review the exercise submissions from last week. We got some really good ones. Removing the default margins and scroll bars that appear on an HTML page. I would like to revisit the topic of tags versus elements because there was some confusion around that. And then we'll go ahead and develop a pseudo scatterplot, a pseudo bar chart, a pseudo line chart, and a pseudo area chart. And I would like to discuss SVG interoperability with Figma and other tools. And if we get to it, we'll add SVG Text and customize the font. Before we get into all of that, I just want to reflect on what we've gotten into so far. It's been HTML, which is comprised of SVG, CSS, and JavaScript. And we have delved into SVG a little bit more. So within that SVG concept, we're looking at circles, lines, and paths. And I think I'll be evolving this diagram as we go to add in all the various concepts that we learn about. Let's review the submissions from last week. The exercise was make something creative with basic SVG shapes. And this is what happens. Here's one submission. I'll click through it and see what it is. This is just gorgeous. Beautiful, beautiful stuff. It's very artistic. And this is what got me thinking of highlighting some of the integrations with design tools. And I want to point out, if you put the link on its own line, it will unfurl like this. You get a little preview in here. So here's another submission. The vision. Beautiful, beautiful stuff. And it's all just SVG right there in the page. Oh, here Nita did one with transitions. Actually, now that I'm here, Nita, would you mind just describing the transitions that are happening here?
Should I talk about it?
Yeah. Can you just talk about it for a few minutes, and
Okay.
I'll highlight the code as you talk about it.
Okay. So we made a basic rectangle using SVG. So rectangle is graphics here, and the properties of these rectangles are width, height, fill, X and Y position, and we can change all of that using CSS language, which is here on the top, style and in the style. So using rect, I'm accessing this rect element in the SVG directly. And what is our aim is to do the transition on it when I'm hovering on a triangle. So what I want to change the fill of it, fill and stroke width. So when I hover on it, the transition is happening at 3000 milliseconds, means 3 seconds here. And in the beginning, the fill of the rectangle is red and stroke is black. And on hover, rect and hover, it's changing the fill to green and stroke width to 100 pixels. So the
Beautiful.
first one is just it shows the CSS properties for rectangle, and the next rect semicolon hover is another state on the first state. So it changes, and that's where the transition comes. Transition is actually between two states. First is when the field is red, and the second state is when field is the green for rectangle. And that's where transition property comes. And we can define that using CSS language.
Nice.
Thank you.
That's awesome. Oh, thank you so much for describing that. That's really great to see.
Thank you.
So yeah, just to recap a little bit, I think this is the first time we're actually using CSS. So when you introduce these style tags, it opens up into a block of CSS. And then these are the CSS selectors. So this selects the body element. This selects all rectangles. And this one, :hover, it says, okay, apply these styles when the thing is hovered over. And so that is cool by itself. And then, when you add this transition, this is one way to animate things with SVG and CSS. So yeah, great one by Nita. This one is really incredible. I was just blown away by this. I mean, look at this. This is just so beautiful. So beautiful. And I want to highlight that when this submission originally came in, it looked like this. And I immediately noticed that there's the default margin that appears with HTML. See on the upper left corner, there's a default margin of some amount of pixels. And then there are scroll bars here. And so these are both undesirable things. And so in the forum, I just said, oh, add this CSS. And I want to just discuss this CSS a little bit because it's very useful for pretty much anything that you do where there's a full screen SVG. This CSS applies to the body element that has a default margin in HTML. And so to get rid of that default margin, we can set the margin CSS property to 0. That will get rid of the margin. But then there do appear these scroll bars, which are kind of a bummer, and I don't really understand why they appear. But anyway, to get rid of those scroll bars, you can add overflow hidden to the body as well. And this gives you a really nice blank canvas where the SVG does fill up the screen. All right, really good stuff. Yeah, here's my comment. That's how you can remove the scroll bars. A couple more. Here's one with some circles. It almost looks like a record. Very cool. Oh, yeah, and you can set the height of things in VizHub. So I noticed with this one, it's actually larger than the page. There's this scroll bar. So you could get rid of the scroll bar. Or another thing that you could do is change the height. There's an option here to set the height. I just wanted to make sure everybody is aware of this. So yeah, you can use that to change the aspect ratio of the viz. And this one also blew my mind. Ha! Look at that. Took my avatar with GIMP and exported the paths to SVG. Pretty wild. And this one also uses the hover CSS selector. So when you hover, it changes the transform, which is a CSS property that you can use to scale and rotate and translate things. So I thought this was very nice work. Very nice work. Here's a flag of Seychelles. Very beautiful. This one uses the polygon construct within HTML. It also uses an H1 element, which is this text here. H1 in HTML means heading 1, so the text is kind of big and bold. And here's Wasim's work. Very nice. Kind of like abstract art. And you can see that it's a bunch of path elements where the only difference is where it moves to initially. And since these are lowercase commands, these are relative, so all you need to do is change that one thing and it moves the whole thing down. And check this out, there's a class on the path element. And a class can be selected with CSS, meaning you can use CSS to select all elements that have a specific class using the dot prefix on the CSS selector. So this one here, this little block of CSS selects this inner path, this one here, and sets the fill to black just on that one. Whereas on all the other ones, the fill is none. So that's a nice, first sighting of CSS classes.
Can I ask a question there?
Yeah.
So what is the difference between ID and class?
Ooh, ID and class.
Yeah. Just could be a basic question.
Let me just fork this so I can modify it and show you to give a sense. So the question is about ID versus class. Class is something that many things can have. So there could be many classes that have the same, there could be many path elements that have the same class, in which case this selector would apply to all of them. There's also a construct called ID, and if you use ID, see how now it's broken, it didn't select. If you use ID, then the prefix on the CSS selector is a hash symbol. So now that should work. Oops, I misspelled ID as IN. So ID is inner path and it works. The main difference between ID and class is that the intention behind ID is that there's only one thing that has a given ID. That's why it's called the ID. It means the identifier for that one particular thing. So ID is for just one element, meaning no two elements should have the same ID, ideally. But class it defines a class of elements, meaning a grouping of multiple elements. So there could be many elements that share the same class. So that's the main difference between ID and class. So going through the submissions and questions here, Nita asked a question about SVG. It says SVG is an XML-based markup language for describing two-dimensional vector graphics. As such, it is text-based and so on. And so the question is SVG a graphics language similar to HTML and XML? Yes. Yes, it is. SVG, in fact, stands on its own as an image format. And so, in a sense, it's not strictly within HTML. SVG exists as a standard for defining images outside of HTML, but it is based on XML. So XML is the language used with the tags and everything. That's the language used inside of SVG images. So I hope that answers the question. Is that clear enough?
Yes, it does.
Nice.
Yeah.
And is everything inside SVG tags text data? Well, this comes to the point of the distinction between the document and the DOM. This came up last time too. I think it was Adil that asked, what is the difference between a tag and an element? And I gave an answer that I don't think was 100% accurate. And Nita did some researching and reading about this. And I wanted to just clarify this point. that in a document, meaning in the text that defines an HTML document, the source code, in the .html file, there are elements there in the sense that the syntax in there defines the element. And that element in the document is comprised of the start tag, the ending tag, and everything in between. Tags, on the other hand, are constructs that only exist in the document. The tags for every element in its definition in the document has two tags, an opening tag and a closing tag. And those tags are purely syntax for defining the elements. But when the document gets loaded and parsed into the browser, it becomes the DOM, the document object model. And in the DOM, it's a tree data structure where there are elements. So if you Google HTML element and read about it, people discuss it in different ways, and they use the same term, element, to define things that are in the source code, meaning, the start tag, the end tag, all the attributes and everything in between. That's often referred to as an element when you're discussing the source code, the document. But there's a distinction between an element in the source code and an element in the living, breathing DOM. And so the living, breathing DOM is a dynamic thing where the elements can change over time. But the element in the document is a one-time thing, like it's fixed when you load the page. So I just wanted to discuss about this a little bit. I hope it clears up any confusion around this. Any remaining questions about this?
Will we be talking about DOM in the future? Because we did not talk about it yet.
Oh yeah, we'll be using the DOM quite a bit. And I think we did talk about it a little bit. Yeah, so if we look at anything in VizHub, I just want to clarify this with some grounding. Here's the begin tag, here's the end tag, and taken together, it defines the element in the source code. Similarly, here's this SVG. All this stuff that I've selected defines this SVG element, and there are elements nested within this. But this is the source code, this is the document. But when it runs in the browser, you can right-click it and say inspect. And that gives you this Chrome DevTools, which is a window into the DOM, not the document, not the source code. And so in this sense, we have touched the DOM by using the Chrome DevTools. And like I said last time, you can manipulate these things, these attributes in here, and it will update. And see, look at that. It actually transitions. So if I set the width to be 400, it transitions because there's a CSS transition applied to it. But what I'm doing here is manipulating the DOM by using the Chrome DevTools. And in the future, we're going to use JavaScript to manipulate the DOM. Yeah, but we're not quite there yet. So going through the submissions, I want to highlight this one by Adil. This is so good. Yeah, check this out. It's this really beautiful animation with the sun setting and the colors changing. So this is just gorgeous, gorgeous work. And Adil is live with us now. And I was hoping we could dive into this a little bit because there are a couple of new constructs used in here, like gradients and animate tags. So Adil, would you like to sort of narrate what's going on here and also describe how you came to create this?
Sure. This was a really fun exercise. I thought of the there was the idea of the sun rising and setting, and automatically thinking, well, how would that affect the surroundings as well? So we have to begin with, I created the sky element as a rectangle, and gave it a fill, and which would be determined by something called the sky gradient, and so this is a linear gradient that sits in a special tag called defs, where it gets defined. And sorry, this was a radial gradient, not a linear one. And it takes an ID, so we can refer to the definition. And it's there is also, it takes a CX and CY property, which is familiar, I think, when we use the circle tag. And what these do is similarly, they define the circle for that gradient, and that the perimeter of that circle can be have a gradient or a color attached to it. So yeah, this was really this was the first time I'd really come across the animate and gradient APIs of SVG.
So I just want to make sure I understand, and just to explain everything, if you change CX to 0, see how the gradient is sort of emanating from this side, and 50% puts it in the middle, and likewise with CY, if you put it to 0, it's emanating from the top. Very, very nice. And I didn't actually know that percentages are the unit here. So I'm learning things as we go. So yeah, I just wanted to tweak those. But yeah, continue, please.
Yes, it takes percentage units, which was interesting, and I may be wrong, but I wonder whether it just corresponds to the position across the screen in terms of how far, in terms of as a percentage, it goes across the screen. So I think this would be 50%, 50% for each of CX and CY would be right in the middle of the screen of the SVG.
Yep.
And there is it takes a radius, which also I think tries to describe again in a percentage, but also tries to describe the width of the overall, where the position of the perimeter would end up. So this was quite new, so I think I think we, after experimenting just like that with the various numbers, I settled on 75, and then but yeah, I was experimenting exactly in that way just to get an idea of what that radius really meant.
Nice.
And there's inside of that radial gradient, there is a stop tag, a couple of stop tags, one that has each of these have an offset property of and one is 0 and the other is 100, and I think this really describes, the offset property describes where that gradient stop is located. And so I think for a radial gradient, it will be the distance from the center to the edges of the circle. Yes, again, I was experimenting exactly like that, just to see how the numbers would translate into different colors across the screen.
Nice.
So that was just and then there was a little so there was a radial gradient used for the sky backdrop, and then 2 linear gradients used for the 2 landscapes in the foreground. And
Actually, before we go on, what is this Q? Is this what makes it curvy?
yes, so I think this is a cubic curve. If I looked up the MDN documentation from last week, and I think this is it might be, sorry, not cubic, but quadratic. Some quadratic Bezier curve. So that will allow, from the current position, which is defined by the first 2, sorry, the second 2, which is see if I just get this right. So it takes a current position, which is defined by what comes after M, where we, as you described last week, that's when we put the ink to paper, or put the pen to paper. And then what comes after Q are 4 numbers. The first 2 of those numbers are control points, and the second 2 are where you would where the final point ends up. So that's 960 is right on the other end of the screen, and again, experimenting. This is how I became a little bit more comfortable with understanding what it does. And the 2 the control points straight after Q, I think these help these are points located somewhere which help describe the curve in the way that it gets pulled towards those control points. Again, lots of experimentation was involved just to see how this could work.
Very nice.
It was fun. Similarly, we had that was again very interesting.
I think that about sums it up. There's linear gradients that use a similar format to the radial gradient, and stops within those. And I'm curious about this animate tag. How did you figure this out?
Yeah, so this was so the problem I was trying to solve here was how could we animate the gradients, so to speak? How could, as the sun is rising and setting, how can the colors change? In this case, this is the this particular landscape I think in the foreground. This would go from Alice blue to steel blue back to Alice blue, and it would do it across a number of seconds. The animate tag was very interesting. You can try and by using something called the attribute name, which is the stop color. You can change the values of the stop color from Alice blue to steel blue and Alice blue. So that's a list of values that you would like it to go through.
Nice.
Again,
beautiful.
So much experimentation.
Yes.
Really to help understand what was really what was going on.
This is really great, Adil. Thank you so much.
It was fun. Thank you.
This might be a good transition with the discussion on control points to using Figma. Figma is this really amazing design tool that I've actually been learning myself for the first time recently, and I've used it to create all of the various pieces of graphics for this series so far. You may be interested to know that the mask that is applied to my video is actually driven by this graphic right here. So that's being masked onto my video, and that's actually how it's working. But anyway, Figma and a lot of different design tools like Figma, including Sketch or Adobe XD, or even like straight vector graphics tools like Adobe Illustrator or Inkscape, which is open source, or GIMP. I believe GIMP has limited SVG capabilities, but it lets you design SVG graphics. And there's this whole interface around it. And because the idea of control points came up, I want to just create a little sample to illustrate control points. So I've got this sort of template here. I'm going to delete this stuff. And there's this thing called the pen tool. And you can use it to define SVG paths. And so there's a path. I can set the stroke and interactively control all this stuff. So instead of having to tweak it little by little in the HTML, you could use a tool like this to very rapidly iterate on stuff like this. And because the control point concept is so abstract, I wanted to illustrate it in a concrete way. And I believe if you drag in here, you can define a control point. And so this dragging defines the control points along this Bezier curve. I think it's a Bezier curve. I may be mistaken. But that is the effect of the control points. So if I grab that and change it around, see, that right there is the control point. It sort of pulls the line in a certain direction. Yeah, so that's the essence of control points. One thing I wanted to do today was pseudo visualizations. And what I mean by that is approximating visualizations. And I want to take a moment to just discuss that sketching and doing mockups in a design tool are actually very important pieces of data visualization work. I mean, when I get involved in a client project, for example, we have a meeting, and then the first thing I do, if they send me the data, I'm lucky. If they don't, I have to imagine the data. But often based on a discussion, I often sketch out something. And this is a popular technique from Nadi Bramer and Shirley Wu. They have data sketches. That whole thing, highly recommend it. But to give a sense, what I do is sketch on a notebook. So I've got all these ideas that I've sketched out. This is for like what I wanted to talk about today and the next episode. And so sketching is the first step. And then once you have a sketch that you like, and sketches, by the way, you can communicate sketches to clients. It's a very effective tool because then they realize that it's sketchy. It's not final in any way. But then once you get a sketch you like, the next step often is to mock it up in a design tool. I mean, sometimes you do go straight to implementing with D3 or whatever, but mocking up something in a design tool is a big part of the process. And I think it would be good for us to do now to cement our understanding of the basic SVG shapes that go into visualizations. So here I am in Figma, which is the tool that I've come to really like for this sort of stuff. And I think you can sign up for a free Figma account and use it for free. I think they charge you when you want to add real-time collaborators. So I'm going to start by making what they call a frame in Figma. This is going to be the sort of container for our SVG. And I'm going to set the width to be 960 and the height to be 500. because that's what the default width and height are in VizHub and in blocks.org. And let's start by creating a pseudo bar chart. Pseudo. Pseudo something means a fake version of the thing. If anybody hasn't heard of that term, pseudo. So, yeah, I wanted to make a pseudo scatter plot, a pseudo bar chart, pseudo line chart. So why don't we start with the pseudo scatter plot? A scatter plot visualization is comprised of circles. And so if you drop in a circle there, I can set the fill here to be black, because we're going to get it right in black and white. And then I'm just going to make a bunch of copies of that circle and position them around the screen, like this. So this is a pseudo scatter plot, really. So I'll just, spread them out a little more, make it sort of aesthetically pleasing. And at this point, I want to highlight the interoperability of SVG between tools like this and HTML. So in Figma, you can select this frame and click on Export, and then select SVG from this drop-down menu here, and then say Export, like that. And then you get a .svg file that you can open up in Chrome, and then you can say View Page Source, and here you have the SVG text, which you can then copy into VizHub. So here I've got the SVG fundamentals from last week. I'm going to fork this and call it pseudo scatterplot. So I'll clear out the README. I'll actually say an approximation of a scatterplot. And then in index.html, I'm going to get rid of that SVG that we had before and paste that text in there, and use Prettier to auto format that. And there we go. We've got a pseudo scatterplot.
Cohen?
Yeah.
Does the xmlns attribute, is that important? Is that necessary?
That's a great question. I believe it might be necessary for .svg files, as in image files that are outside of HTML. Inside of HTML, you really don't need it. It'll work without it. And it gives you actually a lot of stuff that you don't need. You'll see this a lot with programmatically generated SVG. There's a bunch of stuff that's not really necessary. So we could clean up this SVG, like the view box is something that you can use to control the relationship between the actual pixels and like the pixels that you use, the coordinate space that you use to define the shapes. It helps with controlling the aspect ratio. There's some tricks you can do with the view box, but I'm going to delete it because it's not strictly required. And also fill of none on the SVG, that's not required either. And also fill equals black. I'm going to use Vim mode here to delete all of these at once. You don't need the fill equals black because the fill is black by default on all SVG shapes. And this one is suffering from the default margins and the scroll bars issue. So I'm going to just add that style back in to remove the margin. I'm going to select the body element and say margin is 0. See, that moved it up just a little bit. And then overflow is hidden. Okay, that looks decent. So there we go. A pseudo scatterplot. let's do also a pseudo bar chart. I'm going to go back to Figma here. I'm going to make a copy of this frame. I'll delete everything in it by selecting it, hitting delete. We can create rectangles.
Can you give me access to the file?
Oh, sure. Yeah, Figma has real-time collaborations, so I can add you. Can edit. It's an invite. You should be able to see it now. Right, so making this pseudo bar chart, we can just change the fill of this rectangle to be black. And then I will copy this rectangle, move it over, and make it a little smaller. And then do the same thing again. And Figma has this really nice thing where it will sort of snap to proportions that make sense. So like the spacing is now the same, 39 pixels between all of these. And I think I'll make one more. Make it a little smaller. And then I could select all of these and then drag them in. Yeah, Figma has these really cool features where you can move things around all at once, like this. See, this here is a bar chart with no padding. The term is padding between the bars. And when you move them to be spaced out like this, that's introducing some padding between the bars. But anyway, now we have our pseudo bar chart. I'm going to export this as SVG, open it up, view the source, and I'm just going to copy the inside of the SVG because we already have an SVG sort of container in VizHub. Then I'll go back to VizHub here, and I'll fork this, and I'll call it pseudo bar chart. And I'll change the description to say an approximation of a bar chart. And then in the source, I'm going to just delete the stuff in the SVG and paste whatever came out of Figma. And there we have it. There we have a pseudo bar chart. And again, there's some unnecessary stuff. There's a white background rectangle that we don't need because the background is already white. We don't need to fill all of these with black because black is the default fill. And if I run prettier again, it nicely formats itself. So there we have a pseudo bar chart, the essence of a bar chart right here. And I want to point out one thing here, because this point trips up people later on when you end up coding with D3. You might think that you can just change the height of the bars and it'll lay out like this, but that's actually not the case. Look at the y coordinates. I mean, if the y coordinate is the same and we just vary the height, you end up with this inverted bar chart. And this is because in SVG, the coordinate space of the y coordinate, it goes from top to bottom, meaning a y of 0 is at the top, which is again a confusing point. And so what you have to do, you do have to change the height of the bars, but you also need to change the y coordinates of the bars to be the y coordinate of the bottom minus the change in height relative to the biggest bar. And so we'll express all that in code later, but I just want to sort of foreshadow that element, that aspect of bar charts. So let's do some more. A bar chart can also go the other way, meaning instead of being the bars going from left to right and vertical like this, you could have a bar like this, and then have several bars that are, you know, going down the page like this, this format often makes more sense. Mainly because you can position labels to the left of it, and the text of the labels is not sideways. And that's a great lead into text. We can say like, okay, this is bar A, and I can change the size of it. Yeah, so there's like bar A, and this would be like bar B. And these would be replaced with, you know, actual labels in real data viz, but these are pseudo visualizations, so it's just A, B, C, D for now. And the font here I've selected as ShareTech. This is sort of the font that I'll be using throughout the series. In Figma, you can quickly preview different fonts. And I think most of these are available with Google Fonts. But anyway, ShareTech is what it'll be. And then I'll just, you know, adjust this to be pleasing to the eye. And let's export this one as well. Export frame 8. I'll view the source. Copy this stuff. Oh, that's odd. The path has ended up as text. Rather, the text has ended up as paths. I guess that makes sense, so that you can preserve the font. But this is a great opportunity, actually, to introduce fonts in code. So what I'll do is I'll fork this one, pseudo horizontal bar chart, and then I'll paste that SVG right in here. And it worked. There it is. But if you want to programmatically set the text, it'll have to be a little different from this. I mean, if you wanted to change what the text says, you would have to like regenerate this path, which is, it's not something you want to get into doing. So instead, what we can do is define the text as text elements on the SVG. So I'm going to delete all those paths. That gets rid of those letters. And then we can add a text element. So begin text, end text, and this is going to say A. And I want to put it right next to this particular rectangle, so I'm going to inspect it to see what the X and Y coordinates are. So X is 122. And with text elements, you can have X and Y. So I'll say X is 122, just as a starting point, and Y equals 27. And we can't quite see it. What if I say X is 100? I'm not seeing it. Do you have a question?
X could be a little less, I think, then we can see it.
There it is. So it is there.
It's there.
It's just not getting shown. Maybe I need to say explicitly fill is black. There it is. So we've got a little A. Okay, we've got a little A here. Now we want to make it so that it's aligned to this bar, and it is big and it has a specific font. To do that, well, to do a couple of those things, we can use CSS. So we've got this style tag here. We can say select all text elements within the SVG and say font size is, I don't know, 36 pixels. You just have to sort of tweak it. 150. Okay, maybe 120. Or actually, what was it in Figma? I'm going to use the same thing. 72. Okay, now what we want to do is center it. So to do that, I can just tweak the x and the y. So let's say x is 90 or 70, and y should be a little bigger, maybe 40. How about 80? Getting there. 90. 100. That looks about right. And to move it over to the left, I'll make it maybe x is 60. How about 50? There we go. That's approximately the right place. And now I want to introduce the font. The font. And so Google Fonts is the way to go when you want to add custom fonts nowadays. There's a long history of fonts on the web, but you know, this day and age, I would recommend Google Fonts. You are dependent on the Google servers, but I believe all of these fonts are openly licensed. So if you wanted to migrate away from Google Fonts, you could, but you would have to host these font files yourself, which is sort of a pain. But to use any of these fonts now, you can just use Google Fonts, and I'll show you how to do that. So I want to use this font called ShareTech. So you could download it, and then to use it, we can click on Select this style, and it gives you this little snippet of CSS that you can just copy. So it says here, use on the web. Just copy this CSS, or no, this is HTML rather. That includes a link. So in VizHub, I can just paste that right there. Oh, there's some problem. Looks like I've got a syntax error somewhere.
Does it require a closing tag for the link tag?
You know, I think link is one of those things that does not actually require a closing tag. And see, if I get rid of it, the syntax error is still there. Unexpected character at line 55. Oh, I didn't... See, there it is. I didn't add this little character to close out the text. Silly me. Okay, now we're unblocked, and I can paste that stuff up here. And yeah, the link tag is one of those special tags that does not require a closing tag. And I think image is also one of these. So this is a slightly different syntax. This is called a self-closing tag, where it gets closed with the slash right before this character here. But anyway, now that we've got those, these link tags actually pull in the fonts. And then we can set the font family like this by copying this little snippet. So all the text gets this ShareTech font family, and boom, there we have it. All right, so we've got a pseudo bar chart here. We can fill in these labels just by copying this text. I'll make a couple copies of that and move them.
I have a question.
Yeah, sure.
Is the CSS accessing the DOM or just the document?
Oh, yeah, that's a great question. Is the CSS accessing the DOM? Well, it's like the browser is this engine. You could think of it as an engine that takes all of these things as input and works with everything. And so yeah, it's a great question. Does CSS manipulate the DOM? Not really. It's almost like a layer on top of the DOM. But it depends on the DOM for sure. So it's not strictly modifying the DOM. It's like the DOM is there as one thing, and then the CSS is sort of a layer on top of it that describes to the browser how to present that DOM. And so the dependencies are like the CSS depends on the structure of the DOM to function, but the DOM does not depend on the CSS. So it's really a layer on top of the DOM. So once the DOM is there, the browser says, okay, I've got this DOM. I have to present it. How do I present it? Oh, I have to check all the CSS that's there to just see if there's any properties that apply to these elements before I display them on the screen. And so the browser engine internally says, okay, here I've got this text element. I want to display it. What do I do? Which font do I use? Let me go and consult the CSS. Is there any CSS selector that matches this? If so, does it have a font family associated with it? Oh, here it is. Yes, it does. Therefore, I need to use that font family to present that DOM element. So that's generally how it works. Like that's generally the relationship between CSS and the DOM. Does that make sense?
Yeah, so it is always CSS which makes the final decision, or is it a DOM? Like if we have fill color in DOM, same fill in the style for same element, then which one will work first? Which one is dominant?
Oh, which one is dominant? Yeah, that's a really good question. That's a really good, and this trips people up sometimes. So let me give a little demonstration. So I'll say the class here for this rectangle is first bar. And let me set the fill to be red in the HTML. And then in the CSS, we can select that by saying first bar gets a fill of green. And look at that. The CSS actually takes precedence. The CSS overrides what's there in the DOM in terms of the fill. So this is one of those tricky rules, and sometimes I have run into this particular problem. When you're coding with D3 and everything, and you use some code that sets the fill of a particular element to be some color, and it's not working. I've often sat there tearing my hair out, being like, what is even happening? It's a Twilight Zone moment. And so the first thing to do, if your fill or any of these attributes in the DOM, if they're not working, check if there's any CSS that might be overriding it. See, no matter what we set here, if we set this to blue, it's not going to work because there's CSS that is conflicting. And the CSS actually takes priority, which is counterintuitive. I mean, I thought it would make more sense that the attribute in the DOM would take precedence because it's more localized, but it turns out that's not the case. So yeah, for this first bar, we can set the fill to be, let's say, white, and the stroke to be black, and the stroke width to be like 20 pixels. Goes to show you that, yeah, CSS overrides what's in the DOM.
Karan, I have a question relating to this about The fill attribute, is that because we're applying it to an SVG element, it works, but I don't know if I've seen a fill attribute. Would that apply to HTML as well? Because I think I've seen other things like background color or color, or but I don't think I've come across a color a fill attribute for.
Yeah, that's a great question. I believe it is localized only to SVG. It only makes sense to use it with respect to SVG elements. And to clarify this, like if I were to have this question, this is where I would go, the MDN documentation page for fill. And I think there's this notion of a presentation attribute. And that's what the presentation attribute is in the DOM if you set the fill attribute on an element. And I recall somewhere in here there was a list of things that could be used as attributes and also as CSS properties, because there are a couple of these. But I don't know offhand what they are. But definitely fill and definitely stroke and stroke width. But yeah, to answer your question, fill is only applicable to SVG elements. It doesn't make sense outside of SVG, but there are a lot of properties that do apply outside of SVG. Like transform, I think is very generic. It applies to all HTML elements, not just SVG elements. But yeah, fill and stroke, they could be used as attributes, or they could be used as CSS properties. And if they are used as CSS properties, then they dominate the value from the attribute.
Yeah, that's great. Thank you.
Awesome. So before we close out today, I do want to also just do one last pseudo visualization, which is a pseudo line chart. Oh, wait, I've already done that. Look at that. So this is a pseudo line chart right here. It's pretty much an SVG path. And on this point, there are aspects of SVG paths that become important, like the line join. You could have different values for line join to make it either jagged, cut off like this, or rounded. And then there's also the cap. The cap can be set to round, for example, to make the caps round. So as a last pseudo visualization, I'll just make this bigger, export this as SVG, view the page source, copy that into VizHub. This is going to be a pseudo line chart. And then I'll paste that here. Yeah, so that completes our series on pseudo visualizations. Yeah, I was looking at the YouTube chat. The only thing I see is from Wasim, isn't the logic with SVG fill different from regular HTML, in which inline styling dominates over the style tag? That's a great question. I don't know if... I mean, we've just looked at how it is with SVG. With SVG, whatever's in the CSS dominates. But with other types of tags, like straight HTML, I'm actually not sure how it is. I can do a little experimentation. Yeah, let's find out. So here's this thing that Nita made that is sort of an exploration of basic HTML elements. There's the H1 element that ends up as this text. There's the P element, which is a paragraph. H2, which is this smaller text here. And I'm going to fork this and call it investigation of CSS precedence. And in here, oh, this is kind of interesting. There's some missing tags, which is another point we should discuss. But to answer the immediate question, I'm going to introduce a style tag. And I'm going to say for H1 elements, let's make them red. Oh, fill. Sorry, not fill, but rather color. Color is the generic HTML CSS property. Okay, so now that's red. How would we make that red otherwise? I'm sort of grasping at straws here.
You have to do, can I tell you?
Yeah, tell me.
You write style as a property in H1 equals to, and everything else goes in the quotes. Yeah.
Right, yeah. This is called inline styles, which you can do with SVG too, by the way. Yeah, I believe in straight HTML like this, the color is not something, there is no attribute for color. And so you would do inline styles like this. And so in this case, yeah, I see in the YouTube chat, Milo is saying, yeah, both things are style instructions. That's right, yeah. It is CSS. So this is called inline CSS. And the inline CSS does take precedence over the other CSS, the sort of external non-inline CSS. See, if I get rid of that, it becomes green. But if we put the inline style there, it does take precedence over the other style. And I believe it might be the same with SVG. Let me just double check that. So we've got this pseudo horizontal bar chart. And instead of saying fill equals blue, if we say style equals fill is blue, does that take precedence? It does. It does. Look at that. Okay, cool. So we have learned a couple things. Inline styles like this, inline CSS, always takes precedence over CSS defined elsewhere. However, with the attributes, if I say fill equals blue, the CSS takes priority over the attributes. So that's how it all works with the priorities here.
That is so deep.
Yeah. Yeah, this is so great. I love this question format because we can stop and really investigate and get to the bottom of things that people watching are wondering. So, yeah, this is so good. Before we go, I want to leave you all with this exercise. In the forum entry for episode 2, here's the exercise. Recreate a pseudo visualization from one of these visualization taxonomies. And so I invite you to go through these links under data visualization taxonomies and look through all of these and then pick one to reproduce as a pseudo visualization. There's the visual vocabulary, deviation, correlation. See, there's already sort of pseudo visualizations in here. These are great taxonomies of visualization types that you can use as a reference to know how to encode certain types of data. And we'll get into all of the logic behind this later on. But for now, you can just see, there are a bunch of pseudo visualizations here in these various taxonomies. So what I want you to do is look through these, pick one, and reproduce it with SVG in VizHub. You could modify the HTML directly or use some design tool like Figma or others. And here's another one. Really amazing work. These are really fascinating taxonomies of visualizations. From data to viz, another one. Sort of a decision tree based on what sort of variables you use, which chart types to pick. So yeah, go through these links and recreate a pseudo visualization from there and post your VizHub link in this thread. All right, really looking forward to see what you come up with. And thanks for tuning in. I'll see you again next week. Take care. Bye.